Welcome back, everyone. We're going to be solving LeetCode 232, implement a queue using stacks. And I actually had this question as an Amazon interview question when I interviewed with them last year. So it's definitely a good one to know. So they want us to implement a first in, first out queue using only 2 stacks. And the implemented queue should support all the functions of a normal queue: push, peek, pop, and empty. Implement the myQueue class. Void push pushes element X to the back of the queue. Pop removes the element from the front of the queue and returns it. Peek returns the element at the front of the queue. Empty returns true if the queue is empty, false otherwise. And what else do they give us down here? We must use only standard operations of a stack, which means only push to the top, peek, pop, from top, size, and is empty operations are valid. And they also say, depending on our language, a stack may not be supported natively. Okay, so they want us to implement a queue with 2 stacks, so we can just say, in the initialization, we can say self.stackIn is going to be an array or a stack, and then self.stackout will be the same. So when we push an element, we want to push it to this stack in. So we will say self.stackIn.append the x value. Now when we pop from our stack, right, when we pop from the queue, say we're adding in 1, 2, 3 as an example for stack in, right? 1, 2, and 3. When we pop, we want to pop this 1 in constant time, right? That's how a queue works. It was the first one in, so it has to be the very first one out. So how do we do that using 2 stacks? Well, we have to iterate through this stack and then append everything to here from the back, right? So while this stack is not empty, we will take these values, put them in this one. So in that case, it would be 3, 2, and 1. And then this would be empty. And then we can take this value and pop it off. And then we will have to take these remaining elements and then put them back into our stack in. So let's do that. So we'll say while self.stackIn is non-empty, we will say self.stackout.append self.stackIn.pop. And then we will get the last item from self.stackin, or out, sorry. Self.stackout is going to be our value of this pop. So get rid of this. And then after we pop, we have to return those values from this array into the first array. So then we can say while self.stackout is non-empty, we are going to say self.stackIn.append self.stackout.pop. And then we can finally return this this value that we already obtained up here. So that's the pop function. The peek function should return the element at the front of the queue. And to do that, we can just grab the very first item at self.stackIn. So we can say return self.stackIn at position 0, right? That's a constant time. And then empty, we can just say return length of self.stackIn equal to 0. So let's run this. List. I spelled append wrong. Okay. So we'll run this. We pass the test case. We'll submit. And it does run. Perfect. So runtime. What is it? This is going to be constant time. Pushing is going to be constant time. This is going to be, this whole function pop is going to run in O of n plus m time, where n is the length of our stack in, and then m is the length of our stack out. Peak is going to be constant, and empty will also be constant as well.